Hey students, how are you doing today? We are about to study a new topic, and this one is another formula. So we talked about using distance formula in the coordinate plane, and now we're going to find out not only can we find the length of a segment in the coordinate plane, but now we're going to be able to find its midpoint. So that's what we're going to be talking about today, is how do we locate the midpoint of a segment in the coordinate plane. So let's get started. That did not work. Oh my God. Well, I guess I got to be on the right window, but that's okay. Didn't know you could do that. So anyways, on the midpoint formula, we want to talk about the definition of midpoint and also its notation. And how to find the midpoint by measure. So if you're in the coordinate plane and you have horizontal or vertical segments, well, those are a little bit easier to calculate. And also, how do you find the midpoint in the coordinate plane, assuming you don't have a horizontal or vertical segment? There's ways to handle that also. All right, and midpoint is the halfway point between two endpoints of a segment. So it's as if you take a sheet of paper and you fold it in half. You're going to find the midpoint of the length of that sheet of paper. Same thing, if I were to fold this segment up, it would be folded right at this point B. Okay? It's kind of like a book. It would be the binding of the book. Okay, so that's what we're talking about when we say midpoint. It's the halfway point. So if this whole thing were 1 unit in length, then this right here would be half a unit, and this side over here would also be half a unit. So we're talking about the midpoint breaking your segment into two equal parts. Okay? So there's a certain way we notate that also. A midpoint of a segment is the point that divides this segment into two congruent segments. Okay, congruent, don't let that throw you. That just means equal measures. Okay, just like we saw on the last slide. So congruent, that means if I say M is the midpoint here, then this segment BM has the same length or measure as the segment AM. Okay? So M being the midway point or midpoint, it cuts the segment BA or AB in half. Okay? The notation for that is this. I would mark a tick mark, is what we call that, on this segment and on the other piece. So anytime in a geometric figure you see a marking, a tick mark on two different segments, then that's telling you that these two segments are congruent, or they have equal measure. They're the same size, the same length. It could be if I had more than one set of congruent sides or equal measure segments, then I would use multiple tick marks. So I could put 2 tick marks here, and that means each segment with 2 tick marks would be indicated to have the same measure. Okay? Now, if I want to look at finding the midpoint by measure, that's where we talked about having a horizontal or vertical segment. Then I would be able to count right here. Okay? I would be able to count right here. It's 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 units of measure for this segment from -3, 3 all the way over to 5, 3. So the halfway point would be the point where I have 8 units divided by 2. So it would be 4 units from the end point. So if I come over here and count 1, 2, 3, 4, then this point right here in the middle, that is my midpoint. because on the other side, the other segment has a length of 1, 2, 3, 4 units also. Okay? And that applies to segments that are horizontal. It also applies to segments that are vertical. I can easily count the lengths of those segments and then divide it in two and then count that many units from the endpoint. Okay? So I want you to try it. You can pause the video right now. They want to know the midpoint of this line segment. So I want you to use that counting method to tell me where the midpoint of this segment is. So pause the video now and then we'll look at it together. All right, did you find it? All right, good. We're gonna look at this. I'm going from the point 0, 0, point P, all the way to point Q, which is at 6, 0. And I count here 1, 2, 3, 4, 5, 6 units across. So if I take my 6 units and I divide that by 2, 6 divided by 2 is equal to 3. So I know my midpoint sits 3 units from the endpoint. So I'm going to come over here and go 1, 2, 3, and that places my midpoint at x equal 3. Alright, how would we do one like this? Okay, this is one that is a little bit tricky because we don't have a horizontal or vertical segment. This one is actually going to be a diagonal segment, and I'm not sure if I can actually draw a straight line on here. I guess I can try. So we're looking at the segment that goes from this point all the way to this point. Okay, and you can see that doesn't look too easy to find. Okay, it just doesn't. But it's actually easier than you would think. Okay, we have a formula to handle this. Okay, our formula is called the midpoint formula. And all it is if I have the x and y coordinates of each of the endpoints, in this case we'll call them x1 and y1, and x2, y2 is the other endpoint, then I would take the average value of the x coordinates, so that's just x1 plus x2 divided by 2, and that would be the x location. Guess I better get off the ruler and switch back to the pen. That would be the x location. Wow, serious? That would be the x location of I can't get off the ruler. Serious? Oh my gooey. There you go. I had to actually turn the ruler off. This will be the x location of the midpoint. And then if I take the average value of the y coordinates, which is just y1 plus y2 divided by 2, well, that is going to be the y coordinate of my midpoint. So let's see if we can do this problem. So back to our problem, and I'll draw our segment back on here just because. So this is the segment we're trying to find the length of. Okay. And so I want to find the length of this segment. I'm sorry, I don't want to find the length. I want to find the midpoint. I'm back on our other lesson. Wow. So the first thing I would do is label each of these coordinates. Okay, so we're going to label this x1, y1, and this one over here we're going to label x2, y sub 2. Okay, and we know our midpoint is just x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay, so right now we're going to take our coordinates from each of the endpoints and substitute into this formula. So our midpoint x1 is a -5 plus x sub 2 is a 3. And then we're going to divide by 2. And then our y-coordinate of the midpoint, we're going to take 6 as y sub 1 plus 2 as our y sub 2. And we're going to divide that sum by 2. So now it's just a matter of simplifying. We're going to take -5 plus 3 is a -2. Remember, we take the difference. If we're adding unlike signs, we take the difference of the numbers and give it the sign of the larger number. So 5 minus 3 is 2, and give it the sign of negative, which is on the 5. So that's -2 over 2. 6 plus 2 is 8 over 2. And now we know our midpoint is located at -1, because 2 divided by 2 is 1, and 8 divided by 2 is 4. So our midpoint is at -1, 1, 2, 3, 4, which is right here. Okay? So that is the midpoint of this segment. Okay? Now I hope you'll notice something here. You guys know about slope, right? And we know the slope between 2 points on a line has to be the same. So all you have to do is look at this, and I can count over. If I can find, there it is. Right here, that's down to right 4. Here we got down to right 4. Okay? So this is down to right 4, down to right 4. So do you see that? Between the endpoint and the midpoint, I have a slope of -1/2. And between the midpoint and the other endpoint, I have a slope of -1/2. So I can use my slope to actually count over to the midpoint. So you can actually sort of use a counting method on these that are slanted. Now sometimes that midpoint doesn't show up in the nicest of places. It's not going to be at the intersection of the grid lines, and for that one I'd prefer to use the formula for that situation. Here's another example. They want to know where's the midpoint, and again, this is what I was just saying. This midpoint does not show up at the intersection of grid lines, so it's not very pretty midpoint, but again, can we still do it? Well, sure. It's not a problem. We know our midpoint formula is x1 plus x2 divided by 2, and y1 plus y sub 2 divided by 2. And we know that we can locate the endpoints here. Okay? Now they didn't give us the endpoints, but we know how to write the coordinate of our point. This is the point 1, 1, 2, 3, 4, so 1, 4, which we can label this as x1, y1. And then down here we have the point -3, -3. Okay? -3, -3. And this can be x2, y2. Alright, so now all we have to do is substitute into our formula and do some simplification, and we'll have our answer. So our midpoint is x1 is 1, plus our x sub 2 is a -3, divided by 2. Don't forget the division by 2. And then y1 is 4, plus, this is also a -3 for y sub 2, divided by 2. And that means our midpoint is 1 plus -3, which is a -2. That's 3 minus 1, and give it the sign of -3. -2 over 2. And this is 4 plus a -3. That's the same as 4 minus 3, which is a 1 divided by 2. So that means our midpoint is located at -1, 1/2. So again, even though the midpoint doesn't sit at a, quote, nice location because I don't get integer values, It's still an easy calculation. You just simply plug the values of your endpoint coordinates into the formula and simplify. And let's do one more together. So here, I'm going to change pen color on this one. Here we have x1 and y1. This is x sub 2 and y sub 2. And we're going to write down our formula. I always encourage students to write down the formula first and then do your substitution. 2, writing down the formula will help you commit it to memory. Okay? Because this is one you need to memorize. So I have the midpoint. X sub 1 is 4 plus x sub 2 is a negative 2, and all that's divided by 2. And then my y coordinates, y1 is equal to a 3 plus y sub 2 is equal to 1, and then divide by 2. Alright, so my midpoint in this case is 4 plus a negative 2, which is the same as 4 minus 2, which is 2 divided by 2. And then 3 plus 1 is 4 divided by 2. So here our midpoint is 1, comma, and 4 divided by 2 is 2. So that is our answer. That is our midpoint. And we can locate that on the graph. It occurs at 1 and then 2. 1, 2, which is right here. Now this, again, guys, is a grid or a coordinate plane where the units are not 1 unit blocks. They are half unit blocks. So every 2 blocks creates 1 unit. So again, if I were locating the points myself on this particular coordinate plane, I must pay attention to the scale on the x and y axis to make sure I write those points correctly. Okay? And this is what I'm going to let you try. I've placed the formula over here on the right. And then you have... No. What happened? I got some stray marks on my paper. But I'm going to let you guys try this one. Okay, so you can pause the video, and I want you to take these endpoints, label them x1, y1, x2, y2 on your paper, and then substitute into the formula and try and locate the midpoint. Okay? And then we'll see if you're correct. So hit pause now. Alright guys, welcome back. I hope you were successful in finding the midpoint. We are going to look at this, and I hope you did the work. I'm not going to redo the work, but I am going to show you how to use slope to count over. Okay? So if I move over to the right, 1, 2, 3, and then up 1, I find myself at this point. And if I move over 3 units to the right and up 1, I found myself at the end point. So if that's the case, then this must be the midpoint, and its coordinate is located at 6, 5. Was that your answer? Is that what you got using the formula? If so, then you are very successful in locating the midpoint of this segment. If not, I encourage you to pause the video and try that formula again. Look for a mistake in your work and then try and correct it. Thanks. Our next issue is, what if there's no graph? Can we find the endpoint if we're just given 2 points? And the answer to that question is yes. You can still locate the midpoint. All you have to do is label your points. It doesn't matter which one you call x1, y1. Just pick one. I usually take the first one, and that'll be my x1 and my y1. And then my next point I will label x sub 2 and y sub 2. And the formula doesn't change. So we're going to write down the formula. The midpoint is located at x sub 1 plus x sub 2 divided by 2. And y sub 1 plus y sub 2 divided by 2. And now we simply substitute the coordinates from our endpoints. And we are one step closer to finding our endpoint. So x sub 1 is a 2. X sub 2 is a negative 4. And I like to put my negatives inside parentheses. We're going to divide that by 2. And then y sub 1 is 3 plus 11 is y sub 2. And that's divided by 2. So what do we get here? It's funny because our theme seems to be that our x-coordinate of the midpoint keeps working out to a 1 or a negative 1. So here we go again. 4 minus 2 is 2, and give it the sign of the negative 4, which is negative over 2. And then 3 plus 11 is 14 divided by 2. And then I get midpoint is at negative 1 comma 14 divided by 2 is a 7. Okay. So again, if I wanted to check this, all I have to do is go to Desmos. I can graph the point 2, 3. I can graph the point negative 4, 11. And then I can graph my midpoint negative 1, 7. And I should find that that M sits in between point P and Q, and it should be on the same line. So that is something I'll leave to you. You may use your graphing calculator and see if you can graph those points and see what it looks like. But for sake of time on the video, I'm not going to take time to do that at this moment. All right. And now I want you to try it. I want you to pause the video and I want you to label points S and T with your x1, y1, x2, y2. I want you to write down the formula and try your substitution, and then we'll check your answer. Okay? Pause the video now. All right, welcome back. We're going to label these. You might have picked different, but I'm going to do x1, y1, x sub 2, y sub 2. And remember our formula, M. The midpoint, the x-coordinate is x1 plus x sub 2 divided by 2. And the y-coordinate is y sub 1 plus y sub 2 divided by 2. And then we're simply going to substitute our x-coordinates. So x1 is 4 plus 10 divided by 2. And y sub 1 is 1 plus y sub 2 is 5 divided by 2. So our midpoint is at 10 plus 4 is 14 divided by 2. And then 1 plus 5 is 6 divided by 2. So our midpoint is located at 14 divided by 2 is 7, comma 6 divided by 2 is 3. So our midpoint location for segment ST is at 7, comma 3. Is that what you got? If not, pause the video and go back and check your work. Check your substitutions and check your arithmetic, and then see if you can find your mistake. Thanks. So in summary, guys, we can find the midpoint of a segment that is located in the coordinate plane with our midpoint formula. The midpoint formula is basically just the average of the x-coordinates of the endpoints of the segment, which is the x-coordinate of the midpoint, and then the y-coordinate of the midpoint is basically the average of the y-coordinates of the endpoints themselves. So once you locate the endpoints of your segment, you can label your points x1, y1, x2, and y2, and substitute into the formula and do a simplification to get your final midpoint location. Thanks. I hope you enjoyed the lesson, and I hope you experience success in applying this formula on your lesson coming up tomorrow. Thank you.